So we have discussed how to calculate present and future value for a single payment, which is the simplest case. Now, more realistically, you will have a stream of cash flows. For example, if you enter into a loan agreement or mortgage agreement, you will pay mortgage payments every month or make student loan payments every month. So in that case, you have multiple payments. So how to value a stream of multiple payments? And for multiple payments, there are also different cases. Okay, so the first situation that we're going to discuss is when the payments are not equal and they're not necessarily to occur regularly. And the second situation would be more ideal and more like the mortgage agreement, for example, when you have equal payments which occur regularly, and we call those annuity. Okay, so we will start with the irregular, uneven payments, and then we will move on to valuation of an annuity. So the approach for a stream of cash flow, in the general case when payments are not necessarily equal, so you want to start with drawing a timeline. This is optional, but oftentimes you will find it very useful to help you understand and visualize the timing of the cash flows. Then you apply the formula, okay, what we have learned in the previous slides. The future value for single payment or present value for single payment to each single cash flow. Then we want to add up all those future or present values. And later on, I want to also show you a shortcut using the NPV concept or NPV function in Excel to calculate present value of multiple uneven cash flows. So what is a timeline? It's a tool to help us visualize or understand the cash flow schedule. Okay, so just keep it simple. You want to have dates on this timeline and the amount. So for the date, 0 here means today, the beginning. 1, okay, 1 here, the thick line here, that's the end of the first year or first period. Okay, because sometimes it's not necessarily year as the measurement. It could be month, or it could be quarter. And the amount you put here, this is when the payments come. It's not the total balance in the account. It's just indicating at what time how much money is being deposited or being paid. Next tip is to distinguish cash inflow from cash outflow. Okay, so this one here, that's a cash outflow. And then you have cash inflow. Okay, so you can understand this as an investment that you made today, and in return you'll get back 6,000 at the end of year 1, another 6,000 at the end of year 2. So opposite case would be you borrow today from bank, then it will be positive, and in the future you have to make annual payments, then will be negative 6,000, negative 6,000 for the case of a loan agreement, for example. Number 3, representing various time periods. Just change the label from year or months of monthly. Or a lot of times I don't put year here. I know that I'm dealing with year or month. So it's up to you. Okay, so let's look at the first example. Suppose we plan to save $1,000 today and $1,000 at the end of each of the next 2 years. Okay, so we have three deposits, right? 1,000 today, 1,000 at the end of next year, another 1,000 at the end of the second year. So how much will we have 3 years from today? Now this is clearly asking for future value of those three payments. Okay, so we have a timeline here. 1,000 happening today, 1,000 year one, 1,000 end of year two. So there are different approaches depending on your preference. There are different ways to solve this problem. Okay? Some people like to move this 1,000, move this one to year one, calculate the future value, so it would be 1,100. Then they add up the 1,000 that's being saved. So the total would be 2,100. Okay, so at the end of year one, you have a total of 2,100, including the one saved. Then you bring this 2,100 to year two. So the future value will become 2,310 if you multiply this by 1 plus r. And again, you add the amount that's being deposited at the end of year two. So total now is 3,310. And now you bring this amount to year three, noticing that we have no activity here. So it's simply calculating future value of this one for one period. So total now is $3,641. Okay, well, that's the first approach. The second approach, which I usually prefer, and the line of attack I described earlier, is to apply future value to each of these three cash flow. So the 1,000, the future value of this 1,000, I need to do compounding for 3 times, right? So it will be 1,000 times 1 plus r to the third. And for this one, the time of compounding is only 2 years. So we'll be multiplying 1 plus r to the second. And for the last payment, it only stays in the account for 1 year. So there's only one period of compounding. So I calculate all these three future values and add up the total, okay, which is exactly the line of attack I showed you earlier. Okay, let's do one problem. So the investment pays 200 in 1 year, 400 at the end of the second year, 600, and then 800. You can earn 12% on very similar investments. So this is just telling me that I need to use this as a discount rate in calculating present value. What's the most that you should pay for this one? Again, this is a valuation problem. You try to find what should be the value for an investment. And remember that valuation problem, you're looking for present value of all future cash flows. So this is a setup, okay? We apply present value equation to each one of the payments. So 200 divided by 1 plus r, since it's only 1 year from now. For the 400, you divide by 1.12 raised to the second. And 600 discount by 1 plus r to the third, and 800 discounted by 1 plus r to the fourth. Okay, so calculate these and then add up the total. So present value is 1432.93, means that you don't want to pay more than this. This is what the investment worth to you. Okay, you don't want to pay higher than this. So in Excel, what we can do now, using what we have learned previously, is to apply PV function to each of those payments and then add up. Okay, so I'll show you how to do this. Already have the numbers here, So we are going to use the PV function 4 times. Now number of period for the first one is only 1. Payment is 0. And the feature value is this one. Okay, so if you don't want the negative sign, you can change this to, actually, no, that's fine, because this is the amount I received. This is the investment. Okay, so it's okay to leave it negative. And the second payment, also apply PV. Rate is 12. Number of period is now 2. Or you can use cell reference if you want. Payment is 0. This is the future value. Let me see if we can copy this function. Okay, we can also copy this function. Remember, when the little cross show up, when the little cross show up, then you can drag. It will copy function. Okay, so now I'm adding up the total. You can use the sum. Select all these cells. So we'll calculate the total of all these present value. So present value is 1432.93. Okay, the same as this one here.